Welcome to the solution video of this paper 12 Mathematics Cambridge International, May 2023. The language may be different, but they are sure about what is the content. Okay, so let's start with question number 1. The equation of a curve is this: for x is greater than 3, the curve has a point this 4, 5 on it. Find its equation. So whenever we have such a situation, it's a differential equation kind of situation. So what we can do, we can separate dy and dx. Dx goes and multiplies with, not here, multiplies with 4. Yeah, cross multiplication. So 4 dx divided by x minus 3 cube. And now we have two derivatives on two sides, dy on dx separated. So we'll integrate it both sides. So dy on this side and 4, and let me change this to x minus 3 to the power minus 3, and integrate this as well with respect to x. Okay, now integration of dy will be y, and on the right side 4 is a constant, don't touch it. This x minus 3 to the power minus 3 will be going up by 1, and we divide by the same minus 3 plus 1 at the down. Further, we have to divide it by the differentiation. Mind it, differentiation, not integration of x minus 3. Differentiation of x will be 1. Differentiation of minus 3 is 0, so no need. So this one is not going to make any difference, but we should have a habit of dividing it, and then we add plus c. So y equal to 4x minus 3 to the power minus 2 divided by minus 2 times 1, which is minus 2, plus c. And this minus 2, let's make it positive again by bringing it down, and this minus 2 can cancel with 4, which will become minus 2 here. So y equal to minus 2 divided by x minus 3 square plus c. So this is our partial equation, but it's not complete yet. We need to use this 0.45 to get c, and that's what I'm going to do now. In place of y, I will use 5. In place of x, I will use 4 in the equation I got. So 5 is equal to minus 2 over 4 minus 3 square, and then plus c. So c is the only unknown here, which we'll get now. So 5, let's bring it to the left side, plus this minus 2 will become plus 2 divided by 4 minus 3 is 1, and 1 square is 1, equal to c is left on the right side, so c is 7. 5 plus 2, 7. So our final equation becomes y equal to minus 2 x minus 3 square plus 7. Additionally, if you want to write x is greater than 3, this is your answer. Question number 2. The coefficient of x to the power 4 in this expression is p, and the coefficient of x square in this one is q. P plus q is 276. Find the possible values. That means there are more than one values of a. So let's focus on the first one, x to the power 4. When in the power 6 we want power 4, that means x should be given power 4. This x should be given power 4. That means the coefficient of this will be the total number of exponent, which is 6 in this case, c4, which is the exponent of the first content of the bracket. The second one is a, so remaining will be with a, so a will be squared. 4 plus 2 is 6. So this number and this number must match, and their sum 4 plus 2 must be equal to this one. We got it. So let's expand, and then we'll talk about p. So 6 c4 is 15. X to the power 4 will x to the power 4, a square will remain a square. So what is the coefficient of x to the power 4 now? 15 and a square are in front of, you can write this like this, 15 a square, x is 4. So the coefficient of x to the power 4 is 15 a square. This becomes p. Let's talk about the second q. Here in this case we have total exponent 4, so it will become 4, and we want x to the power how much? 2. 4c2, and x has to be given square 2. So x will not be alone, it has a in front of it, so ax will get power 2. Remaining from 4 is 2 again, so the 3 will get 2. So this 2 and this 2 are matching. 2 plus 2 is 4. Both the conditions met. 4c2 is 6, and if I expand this, this square will be applied to both of them, so it will become a square x square, and 3 square is 9. So let's write 54. 6 times 9 is 54. A square x square. So the coefficient of x square here is 54a square. Q comes out to be 54a square. Now the third condition given, p plus q is 276. 15a square is p plus 54a square is q. Their sum is 276. This is how we interpret this based on our two values. So 69a square equal to 276. A square is equal to 276 over 69. 6 times 4, 24. Yes, it is 4. A square is 4. So if we square root both sides, we write a is plus or minus 2. That's why they said values. We have either plus or minus 2. That is the value of a. Question number 3. Express this quadratic expression in the form of completing the square method. That's what they're saying. Okay. Where a and b are integers. Okay, they are integers. And c is to be given in terms of p. Okay, so this is what we have to do. Let's do it. So to convert any quadratic expression into completing the square method, there are a couple of methods, so I will take the one which is easier. If you know the concept, you will understand very well. Okay, so what will I do? I will do this. So what did I do? They wanted an a, so I took 4 common out of the first two terms. So what are we left with? X square inside the bracket, and out of 24, 4 is out, so 24 divided by 4 is 6, minus 6x inside. Okay, now we will add the square of half of this numbers. What is half of 6? 3 square here. So I added 9 to it to make it a perfect square. Okay, so if I have added 9, I have to subtract 9 because this 9 was nowhere before this. So 9 times 4, 36 actually I have added. Not only 9, this 4 times 9 makes it 36. That I will add outside. Okay, so now we know that 4 remains 4 and it becomes a perfect square. A square plus b square minus 2ab. So our the way we write it is square here, square root of x square here, just x, square root of 3 square here, just 3, and the sign of what is in the middle. This is the shortcut. Okay, if I expand this, I'll get back the whole of it back. Okay, plus p minus 36. Right, now the question was where a and b are integers and c is to be given in terms of p, and if I compare with this, this is c here and this is p here, so c is p minus 36. That's the answer. Hence or otherwise, find the set of values of p for which the equation this has no real roots. If some quadratic equation does not have real root, that means the discriminant b square minus 4ac should be less than 0. Okay, it should be a negative number, and that's what we're going to do. What is a here? A is 4, b is minus 24, and C is P. Please don't confuse with this C, okay? This C was in completing the square method. I'm talking about this discriminant. This is what we will take. So B square, which is minus 24 square, minus 4 times A. A is 4 and P is less than 0. So 24 square will be 576 positive, minus 16P less than 0, minus 16P is less than minus 576. We'll divide both sides by minus 16, and when we divide by minus 16 in an inequality, the sign changes. So P is greater than, these become positive both of them, and 16 times 3 is 48 and 16 times 6 is 96. P is greater than 96. This is the set of values of P. So in this case we have taken the otherwise route. Okay, if you wanted to use the hence means use what answer we got earlier. So if you know this 4 is positive, that means this graph will be opening up, and if we don't want any solution, that means this the curve, the vertex must be above 0, right? The y coordinate of the vertex must be above 0 so that it does not cross x-axis and it has some roots. For that we will say that what is the, this is C is the y coordinate. In completing the square or vertex method, C becomes the y coordinate of graph. So P minus 36, which is equal to C in that case, has to be greater than 0, and that makes it P is greater than 36, which we got in otherwise method. Here's question number 4. Solve the equation this, whose degree is 6, and we can see that it's half. 3 power is here and there is no power here. That means we can convert it to quadratic form, because 3 is half of 6. How? We can say that let x cube equal to t. So this becomes 8t square. Why? Because x cube square will be t square. So x to the power 6 is t square. That's why this is t square. Plus 215 t minus 27. There is no x here, so it will remain 27. Now there are plenty of methods where we can solve this. I would prefer splitting the middle term, because 27 times 8, this and this is 216, and 215 is close to this, so I can write 8t square plus 216t minus t minus 27 equal to 0. So I broke 215t into two parts so that I can take 8t common here, so we are left with t plus 27 and negative 1 from here, t plus 27. So t plus 27 is common in both, t plus 27 here, and t minus 1 equal to 0. So this gives us the first answer, not answer, first factor will be equal to 0, and second factor will also be equal to 0, and that will proceed towards the solution. T is x cube plus 27 equal to 0. So back to x. So x cube equal to negative 27, and if we cube root both sides, x is equal to negative 3 here, and x cube equal to 1, and cube root both sides again, x is equal to 1. We could have involved the complex numbers in this, because it has more factors, but they have not given any condition that we can go for them, and this question is worth 3 marks only, so better we stop here. And here comes question number 5. This one says that find the area of the shaded region, and which is nothing but the region between the x-axis and the curve whose equation has been given to us. We just have to find the area, and for that we have to use definite integral between 0 and 4. Why? Because we have 1.00 given here, one is 40, two x intercepts. So we will just write 10x to the power half minus 5 over 2 x to the power 3 over 2 dx and evaluate it. That's it. So first we will integrate this. So rather, for integration we don't need to write this again, so we will write a bracket. 10 is a constant, remains 10. X to the power half, the exponent increases by 1 and the denominator also becomes the same as the exponent. Minus 5 over 2, same thing here, 3 over 2 plus 1 over 3 over 2 plus 1 plus c, from 0 to 4. Let's simplify this one. So half plus 1 is 3 over 2. So this exponent becomes 3 over 2. 10 x to the power 3 over 2 divided by 3 over 2 again. But I will not write 3 over 2 here. I will write what? I will write just 3 here and 2. Denominator of a denominator becomes numerator. It multiplies with the numerator. So it will be 2 times 10 here. Simply same thing here. 5 over 2. X to the power 3 over 2 plus 1 is 5 over 2 again. So 5 over 2 divided by 5 over 2, and that will multiply with the numerator again. Alright, plus c. So what does it become? 20 over 3 x to the power 3 over 2 minus 5 cancels with 5, 2 cancels with 2, so nothing left, just x to the power 5 over 2 plus c, from 0 to 4, that I forgot here. And now substitute 4 first and then 0 and subtract. So I will substitute first 4. 20 over 3 remains 20 over 3. In place of x, I will substitute 4 minus 4 to the power plus c minus, now I'll substitute 0. So 20 over 3, 0 to the power 3 over 2 minus 0 to the power 5 over 2 plus c. Since it is multiplying with 0, this is multiplying with 0, they have no value. This plus c and this, because of this minus, this is minus c, so they also cancel out. That means this becomes our answer, which is 4 to the power 3 over 2 will be 8. 8 times 20 is 160 over 3 minus 4 to the power 5 over 2 will be 32. You can use a calculator if you have any doubt about this. So it becomes what? LCM is 3, 160 minus 96, 64 over 3 units. That is the area of the shaded part. If you want to convert it into decimals, it will be 21.3 units. Okay, they have not mentioned whether it has to be an exact or otherwise, so exact is the best answer. 64 over 3, you can stop here. Question number 6. The diagram shows a sector OAB. You can see this is not C, this is O. Let me complete this properly. OAB is the sector, and in this sector we have this side as x, this side is also as x. That means this is isosceles triangle. We can say that this one is isosceles triangle. This is theta radians. This is the angle between this side and this side, theta radians. Show that the arc length AB is, you could not write it, 2x theta cos theta. That's what they're asking us to show. So arc length is equal to r theta, right? This is what we know. Angle is theta between this side and this side for this sector. This side is radius. This side is x plus something more, which makes it radius. So let's use this one. So r is r, theta is theta, but in this expression there is no r, there is only theta, right? Can you see here? That means this remaining r, we have to show that r is 2x cos theta. This is our challenge, right? Because theta is there, so we'll keep it safe. So this is how we have to show this. Okay, so since this is an isosceles triangle, let me redraw this in proper isosceles way. So this is x, and this is theta. So I have rotated this to some degree so that this becomes an easier one. This side is equal to this side. This will be theta as well, because in isosceles triangle the base angles are equal, right? And if I draw a perpendicular, that perpendicular will bisect this line as well. So this side will be equal to this side. And this whole side is r, isn't it? This side is this side. So let me focus on only the right side. Let me write it r divided by 2. This is half, exactly half of this, because this is isosceles triangle. The altitude divides the base into two equal parts. So this will be half of r. And now we can easily use our trigonometry in this half of the triangle, where we know the adjacent side, we know the hypotenuse. So we will use cos. Cos theta will be adjacent r over 2 over hypotenuse x. So let's cross multiply. This x will go and multiply here. It will become x cos theta equal to r over 2. And now this 2 will also multiply here, and we got what we wanted, 2x cos theta equal to r, and that's why this arc length, which is, what is the name of arc? AB. They are saying AB, or you can write AB arc is equal to 2x cos theta theta. So let me write theta here, cos theta here. This becomes the expression they wanted for r, not r, AB arc. All right. B part, find the area of the shaded region. There's no shaded region here. I've done it manually. So this is what they're saying, APB. This shaded area, they want the area of, in terms of x and theta. So my plan is that I will find the area of this whole sector, area of sector OAB, whole sector, and I will subtract the area of the triangle. What is the name? OPB. Is that OPB, triangle OPB? If I subtract it, remaining will be the shaded area, right? So let's focus on sector. What is the area of the sector? Half r square theta. Yeah, but they say x and theta only know r, but we know r is here, so we will use it later. Minus, what is the area of a triangle? Half AB sine theta. This is the area of a triangle. There is no B here, there is no A, and sine theta may not be theta, so I will just see what is there. So half r is this, so I'll replace r by 2x cos theta. 2x theta cos theta, right? But no, r was needed, not arc. Okay, 2x cos theta is enough. Square, and then multiplied by theta minus half. What is A, B? Any two sides and the angle between them. So we know theta is the angle between x and r. So I'll take these two, and it will be x and r, and theta is theta because the angle between them is theta. Again, I'll have to replace this r also. So let me write here half, and let me write theta first, then it will become 4x square cos square theta. Yeah, 2 square is 4, x square is x square, cos square theta, and then we have theta I've written already in front, minus half x in place of r. Again I will write 2x cos theta, and then sine theta. All right, we have half here, half here. Let's take that common. Theta here, and we don't have any theta. Separate here. So we can't take theta common. 4 here, and what do we have here? 2 here. So we can take 2 common only. X square here. X times x square is here as well. So x square also. Cos square theta, cos theta. So we can take 1 cos theta common. So this is what I've taken common. Let's see what is remaining. Here, half is taken, theta is not taken, so theta will be here. 4, out of 4, 2 is taken out, so remaining is 2. So let me write 2 here. X square is fully out, no need to look at this. 1 cos theta is out, so second cos theta will be written. Minus, half is out, x square is out, 2 is out, cos theta is out, sin theta is remaining. So in this whole, only sin theta is remaining, rest everything is out. So now we can cancel this 2 and this 2, and let's write this simplified version here. X square cos theta, 2 theta cos theta minus sin theta. Can we simplify this further? No. This is the area in terms of x and theta. Question number 7a part 1. Expand this and find 3 solutions of this equation. And this is the domain given, 0 to pi. The theta value should be between 0 to pi, both included. Okay. But we have to expand first, because there are several ways of doing it, but they have given us the hint that we have to expand this one. So let's expand this. So I hope you know this identity. A plus b square is equal to a square plus b square plus 2ab, right? Same thing we'll do here. A is cos theta for us, b is sin theta. So it will be cos square theta plus sin square theta plus 2 cos theta sin theta. And they said this is equal to 1. That's the equation we have to solve. Cos square theta plus sin square theta is also 1. Then we have 2 cos theta sin theta. It is equal to 1. Both sides have 1, so we can cancel. It's like subtracting 1 from here, subtracting 1 from here, so this cancels. We are just left with 2 cos theta sin theta equal to 0. When two expressions multiply and their multiplication is 0, rather in this case there are 3, they are individually equal to 0. 2 cannot be equal to 0, so we'll ignore it, right? That is not true. But this is possible that cos theta, let me write here. So this gives us 2 options. Cos theta is equal to 0 or sin theta is equal to 0. That means theta is cos inverse 0. This will give us theta equal to sin inverse 0. So whenever you have 0, 1 or minus 1 in cos inverse, try not to use calculator. Try to remember what the graph looks like. So the graph of cos looks like this. This is 2 pi. And here we have pi. This is pi by 2. And this is 0. So we can see that cos is 0 when the value of theta is pi by 2. So theta equal to pi by 2. And our domain is up to pi only, so we will not look at this one, which is 3 pi by 2, so we will not look at this. This is the only answer from this left part. Here, if I draw the graph of sine, it will be like this. So 0 at 0, sine is 0, so first answer will be 0, and second answer is pi itself. This is 2 pi. So pi. We will not cross pi because our domain given here is 0 to pi only. So what answer did I get? I got pi by 2 and 0 and pi. These 3 answers are there, and they said find 3 solutions of this. We have found 3 solutions. Now the second part. Hence means use your answers in previous part. Verify that the solutions of cos theta plus sin theta equal to 1. No square this time. In previous part we had square. Let me show you. I think it has gone outside. Yeah. So we have square here. There is no square here. So we will square root both sides. So cos theta plus sin theta equal to 1. This is what we want. And why did they ask us this? Because if we square root both sides, this one and this one, we get this. Cos theta plus sin theta is positive and negative 1. In other words, they're saying that 0 and half pi are the one responsible for positive, and the one which is the third answer, which is pi in previous part, is not applicable to positive, it is applicable to negative. We can clearly see that in this. We will do cos theta, or rather we have to verify. You know what verify means? We have to substitute these answers. So cos 0 plus sin 0 equal to positive 1. That's our real question, not negative. So yes, cos 0 is 1, sin 0 is 0, and it is equal to 1. Verified. Let's see the second one. Cos half pi plus sin half pi equal to 1. Cos half pi is 0. In the graph you can see at half pi it is 0. Plus sin half pi, which is pi by 2, we have 1. The value is 1 at half pi. So 1 equal to 1. Verified. And we will do cos pi plus sin pi also to verify that it is not the right answer. So cos pi is how much? Cos pi is negative 1 here, negative 1, plus sin pi is 0, we can see here, equal to 1, which is not true. So we have verified that these two are the solutions. This is not applicable for given equation. All right. Next part. We have to prove the identity. Okay, let's prove this identity, and it has nothing to do with a part as of now. So we can see the denominator here is cos theta plus sin theta. Here we have cos theta minus sin theta. So whenever we have different denominators, let's focus on the left hand side. Okay, whenever we have different denominators, we do this. Sin theta over cos theta plus sin theta. This is our first term. Second one is 1 minus cos theta over cos theta minus sin theta, correct? What we do, we multiply this with the other one. That's what we normally do, right? If I'm asking you 1 over 2 plus 1 over 3, what do? You multiply this by 3 up and down. You multiply this by 2 up and down. That's what I'm going to do here. I'm going to multiply it by cos theta minus sin theta up and down. Similarly, I'll multiply here cos theta plus sin theta divided by cos theta plus sin theta. So now we have exactly same denominator on both. That means we can simply add the numerators. So sin theta times cos theta will be sin theta cos theta. Sin theta times sin theta will be sin square theta, and that will be negative because there is a negative with sin theta. Plus, there was plus in between, right? Can you see? Here plus. So 1 times cos theta is cos theta. 1 times sin theta is sin theta. Minus cos times minus cos is minus cos square theta. Minus cos times sin will be minus cos theta sin theta. And denominator, exactly same denominator for both. So it is like this identity. A plus B a minus b is equal to a square minus b square. It is also a very famous identity which are we going to use. So a plus b, a minus b, so it will be a square minus b square. Now look at our target. First, let's see denominator, yeah, numerator, this is cancelling. Cos theta sin theta here, minus cos theta sin theta here. And we have nothing. What is our target? Cos theta. Yeah, we have cos theta. Sin theta, we have sin theta. And now we have to see here, look, minus sin square theta minus cos square theta. Since we know that sin square theta plus cos square theta is equal to 1. So minus sin square theta minus cos square theta will be equal to minus 1. So this and this is minus 1. Do we need minus 1 in our numerator? Yes, minus 1. So this is done, and what? Nothing is left. Yeah, cos theta and sin theta left. Plus cos theta plus sin theta. We got our numerator exactly same. Yeah, only the sequence of writing is different. So we done it. Now we want 1 minus 2 sin square theta. That means this cos square theta must be changed, which will be from this identity only 1 minus sin square theta, and we have additional sin square theta, and finally we got, let me write exactly same thing, cos theta plus sin theta minus 1 divided by 1 minus sin square, and sin square becomes 2 sin square theta, which is right hand side. That's why it's proved. Okay. Now using your answer in A part 2. What was A part 2? Okay. A part 2 was that cos theta plus sin theta is 1 for only these two. Okay, this will I'll keep in mind. And B, this is the identity. Okay, and then we have to do what? We have to solve this equation. Solve the equation, this one. Okay, so this one was our LHS, which became RHS, this one. So I can write this one in place of the left hand side. So let me write it. In place of this, I'm writing what I got here. Cos theta plus sin theta minus 1 over 1 minus 2 sin square theta. Okay, which is equal to RHS. I'll write as it is, 2 cos theta plus sin theta minus 1. Okay, so we can see this numerator and this, this is in bracket, are exactly same. This bracket part is exactly same. We can simply cancel them, but no, this is the big mistake in excitement what students do. This is not what we should do. We should bring it to the left side. So it becomes cos theta plus sin theta minus 1 over 1 minus 2 sin square theta minus 2 cos theta plus sin theta minus 1, right, equal to 0, right? Why did I do that? Because I don't want to lose this. By cancelling, this will also give us an answer. Why? Because they have something in common. What is common? Cos theta plus sin theta minus 1. This is common in this and this. So what is left here? 1 over 1 minus 2 sin square theta is left here, minus just 2 here, nothing else, equal to 0. Can you see that? This, because just like the previous part, let me show you where I did that. Here, can you see? Where was that? Here it is. Sin theta cos theta was equal to 0. This one, if you look here, this one, I said either cos theta is 0 or sin theta is 0, because these two are multiplying and they were equal to 0. Exactly same I'm going to do here. What? This part and this part, they are multiplying and their multiplication is equal to 0. That means either this is equal to 0, cos theta plus sin theta minus 1 is equal to 0, or 1 over 1 minus 2 sine square theta minus 2 is equal to 0. This becomes two situations, it will give us answer. This will be cos theta plus sine theta equal to 1. This becomes 1 over 1 minus 2 sine square theta equal to 2. We can cross multiply here. So 1 equal to 2 minus 4 sine square theta equal to, that is done. So now 2 can come here, it will become 1 minus 2 equal to negative 4 sine square theta. Negative 1 equal to negative 4 sine square theta. Divide both sides by negative 4. So this cancels and this positive, they become, two negatives become positive. So sine square theta equal to 1/4. And if I square root, it becomes sine theta equal to plus or minus half. Let me show you the domain we've been given. Domain given was 0 to pi. So let's see what answers we get from 0 to pi in this case. And this, they've all clearly said, use your answer in A second part and B. So A second part I'm using because I already know cos theta plus sine theta equal to 1 has two answers, which are 0 and 1/2, right? Pi. So I straight up give the answer here. So theta equal to 0 and 1/2 pi. They have saved our time, that's why they said so. There's no need to do anything here, we already know these answers. Now what about the other one? This one, plus and minus half from 0 to pi. So let me visualize this. This is 0, this is pi, and sine theta is positive here and here. That means negative is useless here. Negative will be here and here. We will ignore it. So theta becomes sine inverse half, positive half. And what's that? Sine half will be 30 degrees, or in terms of radians, it will be pi over 6. So we will write pi over 6 here and pi over 6 here. So our first answer is starting from 0, this up to this line is our first answer, which is pi by 6. So theta equal to pi by 6. Second answer will be starting from 0 again and reaching the second line, which is here. Second answer will be pi minus pi by 6, which is 5 pi by 6. So we have 4 answers here, which are, let me show the previous ones also. The 4 answers are 0, half pi, pi by 6, and 5 by 6. This is the solution of question number 6. And here is question number 8. Fx is equal to 3 plus 2 sine 1/4 x from 0 to 2 pi. Sketch the graph of inverse of that graph. The original graph y equal to fx has been given to us. So now to sketch the inverse, the process is very simple. Take points where the coordinates are x and y coordinates are same. So 0, 0 is 1, half pi is 1, pi will be the next one, 2, 3 over 2 pi, and then it will be 2 pi, 2 pi. This is the line you have to imagine or draw. Let me draw it better way, and let me use shapes for this. Okay, this is the line I'm going to use, and reflect the original graph on this line and you'll get your inverse. And now try to draw a good curve which will be the reflection of the original graph passing through this, and it is stopping at 2 pi, so it will stop at 2 pi somewhere in middle, right here and middle. So let me, it will be somewhere here. This will be the graph. The yellow color is the graph of the f inverse x, just reflected on y equal to x line, where the x and y coordinates are same. Alright, now we have to write the equation of the inverse, and for that I need the original one. The original one can be written as y equal to 3 plus 2 sine 1/4 x. This is the original equation, correct? If I want to inverse this equation, that means I want to find f inverse x. I'll replace y with x and x with y. 3 plus 2 sine 1/4 y, and now my target will be to isolate this y so that I get a new function. So first I'll remove this 3 so that it becomes x minus 3 on the left, and we are left with 2 sine 1/4 y. Now I have to remove this 2, so I'll divide here by 2 and divide this whole also by 2. Nothing is adding here, so dividing just this 2 is enough. So 2 and 2 cancel out. We are left with let me write that one on the left side now. Sine 1/4 y equal to x minus 3 over 2. Purpose is to isolate this. So sine, if it comes to the other side, we are left with 1/4 of y equal to sine inverse x minus 3 over 2. Alright, and now this 4 has to go, so I'll multiply this by 4 here and multiply here also by 4, so that this 4 cancels here. We are left with y equal to 4 sine inverse x minus 3 over 2. This is the inverse, and formally we can write f inverse x. This y will be replaced by inverse equal to 4 sine inverse x minus 3 over 2. This is our inverse, whose function is this yellow colored graph. What about the C part? Complete the graph of gx. It is different. Gx, is it different from the original one? Original was 3 plus 2 sine 1/4 x, and it is not. Graph is exactly same, only because the domain has changed. It is from minus 2 pi to 2 pi, and that's why it becomes gx, not fx anymore. So gx is still the same equation, 3 plus 2 sine 1/4 x. Okay, so we have to complete this till minus 2 pi. So we can first put minus 2 pi. What is the maximum this one? Maximum of this one will be the axis, the middle one, plus the amplitude, which is this one, 3 plus 2, 5. And we can see 3 over 2 pi is about 4.71, so 5. This is the maximum at 2 pi, that's 5. So this is maximum. What about minimum? Minimum will be 3 minus 2. Axis minus the amplitude, which is just 1. That means minimum will be at minus 2 pi. Let me see. Minus 2 pi is sine minus pi, 3 minus 2, 1. Very good. Yes, at minus 2 pi. Sorry, let me show you how I got this one. So in place of this x, I'll put minus 2 pi. 3 plus 2 sine 1/4 times minus 2 pi. This is the angle. 4 and 2 will cancel. So we'll get 3 plus 2 sine minus pi by 2. So if you put this in a calculator, you'll get 1. 3 plus 2, this is minus 1. So yeah, we'll get 1. So 1 is the minimum at minus 2. So 1 will be how much? Half pi is 1.57. And this will be 0.75. So 1 will be somewhere here. Okay. And now we know that the sine graph is a uniform graph, so it will be, since this is maximum, this is minimum, there is no turning point here. This will be the graph, how it will look like. So complete the graph, this, and hence explain if gx has an inverse. So we have to explain if gx has an inverse, and we'll write, since there is no stationary point or turning point, you can write 2 pi to minus 2 pi to 2 pi gx is 1 to 1 graph, and every 1 to 1 graph has an inverse. So gx has an inverse. So horizontal line will never cross through 2 points. So in the inverse, the vertical line will not cross through 2 points, and that's why it is a function. D. Describe fully the three transformations on y equal to sine x, and the domain given is 0 to pi by 2. Okay. Can we combine to get y equal to fx? Fx means the previous one, the first part. This one. 3 plus 2 sine 1 4. Oh, exactly, they are same thing. Only domain was different side. So let me write here. What they mean here is y equal to 3 plus 2 sine x. All the transformations. So we can see there is a vertical translation of 3. Vertical translation by 3 units up. There is a vertical stretch by a factor of 2, and I forgot to write 1/4 here. This one is horizontal stretch by a factor of 4. So factor of 4, yeah. So because our domain is pi by 2, I insert pi by 2, because of the stretch by 4, it will go up to 2 pi, and that was what the domain of y equal to fx was. That's why it is correct. So now they're saying the sequence has to be combined to get this. They have not typed here. They also said the sequence in which this will be done. Okay. So the translation, this is vertical translation, this is stretch, and this is stretch. Stretches or compressions, in other words, they take place first. So you can say this one first or this one first, doesn't matter, because one is in x direction, one is in y direction. So still I will give this preference. So I will say that this is number 1, happening number 1. This stretch by factor of 4 is happening number 2. And then vertical translation. Translations happen after stretches. This will happen the last. This is the sequence of different transformations. Question number 9. The second term of a GP is 16. So A2 is 16. And the sum to infinity is 100. Find the two possible values of the first term. Okay, that means there A2, if I draw a graph of two GPs, okay, one will obviously start with a higher number, one will start with a lower number. The second term is equal, that means their graphs will be crossing at 16 when y is 16. If I say this is okay, this is the an and this is n, and they go to infinity at the same level. So what is actually they're saying sum to infinity means the area under this curve will be equal to the area under the other curve, right? So it's possible. Okay, so let's interpret them. A2 first. An in GP is AR to the power n minus 1. They say it is equal to, in place of 2 it is 16. So I'll have to undo this, and right here A2 will be the first term multiplied by the common ratio to the power 2 minus 1. So A2 is how much? 16 equal to AR. This is our first equation through this information. S infinity, which is 100, equal to, the formula for S infinity is A over 1 minus R. So A over 1 minus R. So find the two possible values of first term, that means A. Yeah, A is the first term. So I'll isolate R in this case. So let me isolate R here. R equal to 16 over A. This we can substitute here. So 100 equal to A over 1 minus 16 over A. Let's do cross multiplication in this case. This is 1 now. This whole 1 minus 16 over A multiplies here. So 1 times 100 is 100 minus 16 over A times 100 will be 1600 A over A equal to A. Yeah, this is the A, only this A will be left here. Now we need to get rid of this denominator here, so we will multiply the whole equation by A so that this A and this A will cancel when we multiply here. So first this A will multiply with 100. Then this A multiplies with this, but this A and this A will cancel, so we are left with only 1600. And A times A will be A square. Let's bring these two terms to the right side so that it becomes a quadratic equation, and yes, we will get a quadratic equation, so those two solutions will be there. Okay, I can clearly see 1600 will be 80 times 20, and 80 plus 20 is 100, so I can use splitting the middle term method here. So minus 80A minus 20A plus 1600. No change in these two, but middle one is written as this. Why? Because this will give us the solution. A taken common from this, so A minus 80 minus 20 taken common from this, A minus 80. And both of them have A minus 80, so A minus 80, A minus 20 left equal to 0. A minus 20. So this gives us answer A equal to 80 and A equal to 20. So they said, what did they say? Find the two possible values of the first term. These are the two possible values of first term. That is, the lower one is 20, the upper one is 80. Where they are meeting here is 16. Okay. B part. Show that the nth term of one of the possible GPs is equal to this 4 to the power something times multiplied by the nth term of the second GP. And most of this is second term. We can see that this is second term. So mostly the one which has initial value 20 is above the one which has 80 as first value. So we will write this GP divided by this GP, and it should be equal to this. So show that the nth term of one of the two possible GPs is this times the other one. That means the ratio one divided by the other will be this one. So GP1 divided by GP2 is 4 to the power n minus 2. This is what we have to show. So GP1, I'll take 20, this one as A, and we got one relationship here. R equal to 16. Let me find here. R equal to 16 over 20 will be 4/5. So in this case, R is 4/5. What about the second one? Let's call it R1, R2. In second case, A is 80. So 16 divided by 80, 1/5. So here R is 1/5. And now, nth term of GP, right? So nth term of GP. So the first one will be 20. Nth term, let's let the formula of nth term. An is equal to AR to the power n minus 1. This is the nth term. So GP1, it will become 20 times 4/5. 4/5 to the power n minus 1 divided by 80 was the first term, but R is 1/5 and n minus 1, and I can't write it is equal to this. I have to show this. I I can't use this, so I'll keep it and I'll have to arrive at this answer. So we can see 20 and 80 cancels, 4 here and 1 here. So what do we get? 4/5 to the power n minus 1 divided by 4, 1/5 to the power n minus 1. The exponential law says that if two numbers which are dividing, they have exactly same exponent, we can merge them. So it will become 1 over 4, 4 over 5 divided by 1 over 5 to the power n minus 1. So both are inside the bracket now. N minus 1 is the exponent and this divided by this. So let me make more space. 1 over 4, 4/5 times 5 over 1 n power minus 1, 5 and 5 cancel. So we get 1/4 times 4 to the power n minus 1. And since now this is 4, we can simplify them. 4 to the power n minus 1, and this, because it's dividing, it will be minus 1. 4 to the power n minus 2. Got it. The ratio of the two GPs, the nth term of two GPs is 4 to the power n minus 2. Question number 10. The equation of a circle is this, and the line half x plus 6 y equal to half x plus 6 is a tangent. So let me try to draw a line on this of white color. Okay, at P. So let's name this point as P. Show that one of the possible values of A is 4 and find the other possible value. So at P, we can see that at P, x and y both coordinates are same for the line as well as the circle, but I'm focusing on y coordinate only. So y coordinate is same for circle and line. So we can equate this y equal to this y. So I will substitute it. So it will remain x minus a square plus, in place of this y, I will write now half x plus 6, and then we have minus 3 additionally, square equal to 20. So this is the y I have substituted, and now I will expand this. So it will become, we know this, I hope you know this, a minus b whole square is a square plus b square minus 2ab. That's what I'm going to use in this one. So x square plus a square minus 2ax is the expansion of this one. Here 6 minus 3 is positive 3. So I will take this as half x plus 3 and square it by the same identity. So half x square will be 1/4 of x square. 3 square will be 9 minus 2 times half times 3, and not minus, positive this time. Why? 6 minus 3 is positive 3, so positive I'll take here. So the identity, if this is positive, we get plus 2ab. So that's why I'm writing is positive. Done. Yeah, equal to 20. So now we can combine the like terms. 1 plus 1/4 is 5/4. 5/4 x square. So we can write here 3x. Yeah, 3x minus 2ax, and then we can write a square without x, that means this is a constant. 9 minus 20 equal to 0. This 20 also taken to the left side. So 5/4 x square, and let's take x common from these two. 3 minus 2a, and 9 minus 20 will be 11. So plus a square minus 11 equal to 0. Now we know that the tangent, the line and the circle meet at only one point. That means this quadratic equation will have only one solution, and discriminant b square minus 4ac is equal to 0 for one solution. So we'll do that here. This is b, this is a, and this is c. So 3 minus 2a square, that becomes b square, minus 4 times a is 5/4, c, a square minus 11, and that will be equal to 0, and this will give us the values of a. So let's expand this again by the same identity I used earlier. A square, which is 9, 3 square is 9, plus 2a square will be 4a square minus 2 times 3 times 2a. In this 4 and 4 cancel, so minus 5 times a square is minus 5a square. Minus 5 times minus 11 will be positive, 55 equal to 0. 4a square minus a square will be minus 5a square will be minus a square. Okay, we have 6 times 2, 12, minus 12a. 9 plus 55 is 64 equal to 0. Okay, now this is a simple quadratic which we need to solve. Negative a square looks odd, so I'll change the signs of all of them. My new equation will be a square plus 12a minus 64 equal to 0. For simplicity's sake, I have changed the sign of all of them. I can do that. It's allowed. Now 64, 16 times 4. So I'll split the middle term again. So a square 16a minus 4a minus 64 equal to 0. A is taken common here, a plus 16 minus 4 taken common here, a plus 16 equal to 0. And the two factors will become a plus 16, which is in both. What is left? A minus 4 equal to 0. So this gives us a equal to negative 16. This gives us to a equal to 4. So we showed that one of the possible values of a is 4, which was asked. The other value of a is negative 16. This is what we got. What next? For a equal to 4, this one, so let's say that this is 4, okay? Find the equation of the normal to the tangent. Normal, not the tangent. Normal, equation of the normal. So I need a point. Okay, I can use this point because they're saying a is 4 now. So x minus 4 square plus y minus 3 square equal to 20. What it means? That the coordinates of center are 4 and 3. 4 and 3. The negative of whatever are numbers here, that becomes the center, and the radius is 20. Rather, not 20, square root 20. This radius. But we need the equation of this normal. This is 90 degree to the tangent. We want its equation. What we know, so that means y coordinate is not needed here for now. So what we know, that the gradient of the tangent was half x. So gradient of normal will be negative reciprocal of half, which is minus 2. So our equation will be y equal to minus 2x plus c. Now c is the one we need to find out, and we know this point, the center is on the normal, so we can find value of c now. So let's substitute 4 and 3 here in place of x and y. So 3 equal to minus 2 times 4 plus c minus 8. So it's 3 plus 11, no 8, e equal to c, yeah, minus 8 becomes positive 8 that side, so c is equal to 11. So our equation of the normal becomes y equal to minus 2x plus 11. All right, what next? Next one is that for a equal to 4, the one we just found out, find the equations of two tangent to the circle which are parallel to the normal found in part B. Okay, that means we have to find the equation of the normal which will be in this direction. And second one will be here, but I'm not focusing. I'm focusing on only this one. This will be, let's say, mn are the coordinates of this point where it is parallel to this normal, right? And it's a tangent. This is find the equations of the tangent. So let's find the value of m and n, and we'll get the equation of those tangents. So we know this is 4, 3. So this is the normal, this is the tangent. Okay, let's go back to our space there and redraw this. Try to redraw this one. Okay, circle was here, center is 4, 3. I want the coordinates of m, n, so that I can find the tangents equation. One will be here, the other one will be on the other side here, but I'm not focusing on that. I'm just trying to find values of mn. So we know that this normal at this particular mn, the gradient will be half, yeah, because it was parallel to that tangent here. So it is half. So we can say that n minus 3 divided by m minus 4 is half. And cross multiplying, this 2 will multiply over here, 1 will go there. So 2 times n minus 3 is equal to m minus 4. This will be useful for future. So now the equation of the circle is x minus a square plus y minus 3 square equal to 20. And let's substitute whatever we know for this tangent at this point mn. X is m, minus a is given as 4, plus n is the y coordinate, minus 3 square equal to 20. Here we know that m minus 4 is equal to twice n minus 3. So in place of this m minus 4, I will write twice 3 square plus n minus 3 square equal to 20. Let's open the bracket. It becomes 4n minus 3 square plus n minus equal to 20. They're exactly same, like terms. It becomes 5 n minus 3 square equal to 20. Divide both sides by 5. So n minus 3 square equal to 20 divided by 5, which is 4. Square root both sides now. N minus 3 equal to plus n minus 2. So 1 plus 2 is for one end and minus 2 is for the other end. So now I know both. I can find the coordinates. So let's see what two coordinates it gives us. N minus 3 equal to positive 2, n minus 3 equal to negative 2. It gives me n equal to 3 plus 2, 5. This gives me n equal to 3 minus 2, 1. So we got two n's. Let's find the respective m's, and we can use this one. This one we can use. So this gives us 2 times n minus 3, n is 5 in this case. 5 minus 3 is equal to m minus 4. 5 minus 3 is 2, 2 times 2 is 4, and this 4 also comes here. 4 plus 4 equal to m, which is 8. So the coordinates become 8 and 5. Alright, so we'll find the equation first. Let's find the equation of this one. Equation of the first tangent will be y equal to mx plus c, right? That is the format we have. We know the gradient of this tangent is -2 because it is parallel to this normal of the previous part. So, and y will substitute as 5, x we substitute as 8. So 5 is equal to -2, 8 plus c, minus 16 plus, it goes here, 5 plus 16 equal to c, 21. So the equation of the first tangent becomes y equal to -2x plus 21. Let's focus on the second one where n is 1. So we'll use the same method here. 2 times 1 minus 3 equal to m minus 4. 1 minus 3 is -2. -2 times 2 is -4. This -4 will come to the left side, becomes +4, 0. So we got 0 here. So it will be 0, m is x, yeah, 0 and 1. So let's find the equation of the tangent which will pass through this point here. Y equal to mx plus c again. So in this case y is 1 equal to -2, x is 0 plus c. 2 times 0 is 0. So c is 1. The equation of second tangent y equal to -2x plus 1. Done. Question 11. The equation of the curve is this and k is a positive constant here. Find dy over dx. That means we have to differentiate it. This is the a part. So simply dy over dx will be differentiation of this first, which will be k is a constant, so k will remain k. This 4x plus 1 can be written as 4x plus 1 to the power half, right? Because we are differentiating, so it will go down by 1. And further we have to multiply it by the differentiation of what is inside. Differentiation of 4x is just 4. Differentiation of 1 is 0. So we will be multiplying with 4. And this half needs to come in front. This is the differentiation of this part. Minus x. The differentiation of minus x will be -1. Differentiation of 5 is again 0, so no need to go further. Let's simplify this. Dy over dx, and it will be k over 2, and half minus 1 is minus half. So 4x plus 1 to the power minus half times 4. So let's write that 4 here, this 4. Minus 1. So dy over dx equal to 2 and 4 can cancel. So now we're left with just 2 here, and because this is negative half, it will become a denominator which is square root 4x plus 1 minus 1. And yes, k was left here, so k. This is the differentiation of the given curve dy over dx. Find the x coordinate of the stationary point in terms of k. So stationary point is the one where the curve returns back and the tangent there is 0. A tangent, gradient of tangent is nothing but dy over dx. That is, this dy over dx has to be equal to 0, which means 2k over square root 4x plus 1 has minus 1 equal to 0. Let's bring this 1 to the other side. So it becomes what? 2k over square root 4x plus 1 equal to 1. Cross multiply, this will go up. So 2k equal to square root 4x plus 1. Let's square both sides. So it will be 4k square equal to 4x plus 1. We want to isolate x because they want x coordinates. So this 1 will go to the other side. 4k square minus 1 equal to 4x, and then divide both sides by 4. 4 cancel here, so x coordinate will be 4k square minus 1 over 4 in terms of k. Given that k is 10.5, find the equation of the normal to the curve at the point where tangent to the curve makes an angle of tan inverse 2. Suppose this is the curve and this is x-axis, okay? With the positive x-axis, it is making an angle of tan inverse 2. That means the tangent is making an angle such that the gradient of that tangent is 2. This is what they mean. So the interpretation of this line, tangent to the curve makes an angle of tan inverse 2. In other words, they're asking you to make the gradient equal to 2. And gradient is nothing but dy over dx, which is equal to 2. And dy over dx was this one, right, in terms of 2, in terms of k. So dy over dx will be 2 times, and k is 10.5 over square root 4x plus 1 minus 1, and m is 2. That's what we know from here. So this minus 1 can come here, so 21 over square root 4x plus 1 is equal to 2 plus 1, 3. So let's cross multiply 21 over 3. This 3 will go down and 4x plus 1 will come up. Okay, so what do we get here? 7. 3 times 7 is 21. Okay. Now square both sides so that we get the x coordinate. Okay, so 7 square will be 49 equal to 4x plus 1. Bring it here. 49 minus 1 equal to 4x. 48 equal to 4x. Divide both sides by 4, so x is equal to 12. What do we want? We want the equation of the normal, okay, not tangent. So we know x coordinate, we know m, and now we can find y coordinate also. So let's find y coordinate on the curve, and the equation of the curve was this: y equal to k. K is 10.5, 4x plus 1 minus x plus 5. So 10.5, 4x, x is 12 now, plus 1 minus x plus 5. Okay, so 13, sorry, it was 4x, so 12 plus 1, 48 plus 1, 49. Square root of 49 is 7, so 10.5 times 7 minus 7, yeah, minus 12 plus 5 will be negative 7. So let's take 7 common, so will be 10.5 minus 1, 9.5 times 7. So that will be how much? 35, 63 plus 3, 66.5. This is the y coordinate, and now we can find the equation of the tangent. equation of the tangent is y minus y coordinate of the point on the tangent, on the normal rather, equal to 1 over m minus 1 over m x minus x1, where m is the gradient of the tangent, not normal. So we'll substitute everything. Y will remain y, but y we got 66.5 equal to negative 1 over the gradient of tangent is 2 x minus, and x we got as 12. So let's try to, this decimal will create trouble. Have they given any format? So no. So we can give any format we want. So equal to, let's write it as 0.5. So negative 0.5x, and then here plus 12 divided by 2 is 6. So y equal to negative 0.5x, and this comes here, becomes positive, plus 72.5. If this is okay, you can leave it like this or make them proper fractions. Y equal to negative half x plus 72, 145 over 2. This is the fraction version of this.